that blank between consecutive terms is blank. The difference between the consecutive terms is not constant. However, there is something special. I don't know what I want there. Something special between successive terms. There's a common ratio. Okay, so there's a common ratio, and we're going to call it R between the consecutive terms. Can anybody tell me what the common ratio would be for 1, 2, 4, 8? Yes, we are doubling it each time. So the way to calculate the common ratio is you take the next term and divide it by the previous term. So for instance, term 2, if I take term 2 and divide by term 1, I'll get 2. If I take term 3 and divide by term 2, I will get 2. If I take term 4 and divide by term 3, I will get 8 divided by 4 is 2, and so on. It's just like subtracting in arithmetic sequences. If you take the third term and subtract the second term, you'll get the common difference. If you take the second term and subtract the first term, you'll get the common difference. You'll always get the common difference when you're go backwards. Same with this one. Okay, so no matter what you see, you might think you're dividing, but really you're multiplying by a fraction probably instead of dividing. So that's the thing. So a geometric sequence is a sequence with a common ratio between the consecutive terms. A geometric sequence, I just thought that was kind of weird that I'm saying it again. A geometric sequence is produced by multiplying one term by a common ratio to get the next term. Geometric sequences are useful for making predictions about quantities that grows exponentially. So if you think about science classes, bacteria growth, one bacterium doubles or splits in two and you get 2, and then those 2 split in 2 and you get 4. You know what I'm talking about? Same with populations. You know, you find your significant other and you have children and those children have children and yada yada yada. The population just keeps on going, right? Okay. State whether the following sequences are arithmetic, geometric, or neither. If it's geometric, state the ratio R. If it's arithmetic, state the common difference D. Okay. 7, 10, 13, 16. So what is this? Yeah, so I'm going to call it AS for arithmetic sequence. And my common difference is 3. Okay, why don't you see if you can figure out what these are? How about this one? Negative 3, 15, negative 75, 375. It is geometric, and what is the common ratio? Negative 5. I'm multiplying by negative 5 each time. Okay, how about this one? And if you didn't know, by the way, all you have to do is go 15 divided by negative 3 and you get negative 5, or negative 75 divided by 15 and you'll get negative 5, right? Okay, so next one, 1/2, 1/6, 1/18, 1/54. What is this? It's geometric, and yeah, the ratio is 1/3. So if you didn't know how to get that, some people thought you were multiplying by 3. It's not. So again, you do 1/6 divided by 1/2, which is the same thing as 1/6 times 2/1. Do you see I'm getting 1/3? I can do that for a couple terms, but anyways. So what about the next one? Yeah, you're cubing. So is that an arithmetic or a geometric? Neither. Part of the problem now is you're going to have 2 types of sequences, and then they'll throw in something like this where it's neither. And you can't use formulas for arithmetic if it's not an arithmetic. You can't use formulas for geometric if it's not geometric, right? Okay, how about this one? Yeah, you could argue that it's a geometric sequence. The ratio is -1, but we'll learn later that technically it's not really considered a sequence because it's not actually growing or decreasing. It's kind of just what's called it's bouncing essentially. Yeah. I probably wouldn't ask that because it's kind of a gray area there. Okay. AB, what's up? Yeah, you're multiplying by B, so the ratio is B. Okay, any questions there? Okay, next one. So to find any term Tn in the geometric, let's go back and see if we can come up with this formula. So if we're starting with the first term, and we're going to the second term, and we're doubling it, right? We're timesing by 2. And I go from 1 to 4, what am I in fact multiplying it by? 2 squared. Yes, very good. 2 squared. And if I'm going from 1 to 8, I'm actually multiplying by 2 to the power 3 to the first term. So does anybody think they could come up with, and 2 was the common ratio, by the way. So does anybody think they could come up with the formula for a geometric sequence? That's all you got? Well, we took the first term, which was T1, and we times it by the common ratio to a certain power. What was the certain power? Let's see if we can figure out what the power is. So this was the second term, and I multiplied it by 2 to the power 1. This was the third term, and I multiplied it by 2 to the power 2. N minus 1, yes. N minus 1. It's always 1 less than the term number. So Tn, of course, is, I know a lot of times we say it's the ending term, but it's the value of the nth term. T1 is the value of the first term. Okay, R is the common ratio, and N is the term number. Okay, so write a generating formula for a sequence with a common ratio of 3 and the first term is 2. So we're just trying to find Tn, right? So if Tn equals T1R to the power n minus 1, let's sub in what we know. What do we know? T1 is 2. What do we know here? R is 3. So 2 times 3 to the power n minus 1. That's all we need to do. So if I wanted to find the fifth term, T5, I'd put 5 into the exponent. 5 minus 1 is 4, and I'd go 2 times 3 to the power 4, right? Yes? If I wanted to find the 10th term, n would be 10. 10 minus 1 is 9. So if I wanted to find the 10th term, it would be 2 times 3 to the power 9. Got it? Okay, let's find the generating formula for 5, 10, 20, 40. So what are we doing each time? Yes, my R is 2. Does everybody agree R is 2? And of course, right there is my first term, T1 is 5. So my Tn would be what? 5 times 2 to the power n minus 1. Okay, so they've given you the generating formula, for example, 4, and we need to evaluate what term 1 is, term 2, term 3, and term 4 is. So basically, it's just a matter of using the formula there. It's negative 2 to the power n. So you got to watch. There's a difference between negative 2 to the power n and negative 2 to the power n. Does everybody understand that? When you have a negative 2 to the power n, that means remember BEDMAS? BEDMAS says you do exponents before multiplying. So you need to do the exponent part before multiplying by essentially a -1. Whereas this one is saying you're taking the whole thing to that power, right? Okay, so let's try this now. Term 1 would be -2 to the power 1. So what's my answer? -2. Does everybody agree it's -2? Term 2 would be -2 to the power 2. What's my answer? Does everybody see it's -4? Because again, I'm evaluating the exponent before the multiply of -1. Term 3 is -2 to the power 3. So what's my answer? -8. And term 4 is -2 to the power 4, which would be -16. Okay, keep on answering some questions with our formula. Given the sequence 2, 4, 8, 16, find the nth term. The nth term would mean find the formula, right? So sometimes it's kind of intertwined with how they ask things. So if they ask for nth term, that's basically the generating formula. So first term is 2. What's my common ratio? What's my common ratio? 2. Yes? So Tn would be the first term, which is 2 times 2 to the power n minus 1. Now, in some of your homework tonight, if they have the same base, they actually simplify it further. So does anybody know what this would be if I simplified this further? No. You cannot do multiply before exponents. You have to do exponents first. What's this power right here? 1. And what do you do when you multiply the same base? What do you do when you multiply the same base? You add the exponents. So what would I get? 2 to the power n. 1 plus n minus 1, the ones would cancel and you're still left with the n, so 2 to the power n. Yes? So if I want to find the 10th term, that would be 2 to the power 10. Does anybody know 2 to the power 10? 1024. Very good. The 21st term, I doubt you know that one. Oh, you're just way ahead of me, I guess. 2,097,152. How would I figure out what n is if I knew that the value was 4,096? $4,096. Well, it already says it equals Tn. What's Tn equal? 2 to the power n. So at this point, in grade 12, we actually learn how to figure this out. But at this point, you could still figure this out, or you can just do guess and check until you get whatever that exponent would be for that to work, right? Okay, so how I would do this, and I don't even need a calculator to do this, is I would try to figure out how many times 2 goes into 4,096. And you think that's like craziness, but it's not. 2 goes into 4 twice, 048. 2 goes into that, 1024. 2 goes into that, 512. This is what they teach you in the masters, you know. 2 goes into 5, 2, nobody gets my jokes. 2 goes into 11, 5, 6. 2 goes into 2, 1, 2, 8. 2 goes into that 64. 2 goes in that 32. 2 goes into that 16. 2 goes into that 8. 2 goes into that 4. Then 2 and 2. So how many 2s do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means n has to be 12. It's up to you. You can just guess and check. You could just randomly, you have your calculator for this test. You could just randomly pick like 2 to the power 9, does it work? 2 to the power 10, does it work? 2 to the power, you know what I mean, until you get it, right? As long as you understand what you're looking for, it's all good. But this would be the way to actually get it exactly. All right. Continuing. Given the following geometric sequence, find the following term. The 12th term. Okay, so what are we going to do to figure this out? Well, what do we know here? What's my first term? 6. What's my common ratio? So, how do I find the 12th term? T1, which is 6 times the ratio to the power n minus 1. What's my n? Right there is my n, right? N equals 12. So this is going to be to the power 11. If I lost anybody, I'm using the formula Tn equals T1 r to the power n minus 1. Does everybody see that? So I'm just subbing in what I know, and I'm just going to plug her into my calculator. And what do I get? Do you get 12,288? Anybody else get that? Okay, what's my first term? T1 is 10. What's my common ratio? It is 1.5. If you didn't know it was 1.5, take 15 and divide by 10. Take 22.5, divide by 15. You get 1.5. So if I want to find term 8 is going to be the first term, which is 10, times 1.5 to the power n minus 2, sorry, n minus 1, which is 7. So I plug her in, and I get, what do I get? Did you get 170.859375? Yeah. Yeah, your calculator isn't rounding at this point, so I would write everything. So this is T20 would be 10 times 1.5 to the power 19. This one might be only doing, so you get 22,168.3782. This is the best question ever. Have you ever heard this question before? If you earn 1 cent on the first day and 2 cents on the second and 4 cents on the third. There's all these alterations of this where they say, do you take $1,000 or do you take what you'd get on the 30th day? You never heard of this before? It's alterations of what this question is. Basically, if somebody deposits 1 cent into your bank account and the next day 2 cents, then 4 cents, then 8 cents, would you take the money at the end of 30 days or would you take $1,000? Exactly, and you know how much you would make by using your geometric sequences. Because if your term 1 is 0.01 for 1 cent, right? And what's my common ratio? 2, because I'm doubling it. If I want to know on the 30th day, I'd be finding T30. So if I figure this out, I have 0.01 times 2 to the power 29. And so what do you get there? You get 5 million and something, right? Yes? 5 million? Huh? 5,368,709.12? Yes? So I think I would take the 5 million over $1,000. Don't you think? Yeah, that's a great thing. Okay, a geometric mean. When given a geometric sequence with non-consecutive terms, do you know what non-consecutive means? Not terms in between. All the missing terms are called geometric means. So when you find an arithmetic mean, you add them up and divide by how many you have, right? Like if you wanted to find your average in this class, that's an arithmetic mean. You add up all your tests and divide by how many there are, right? Well, a geometric mean means you multiply all those tests and then how many there are. So say you had 8 tests like we do in this, you would 8 root it, and that would be your geometric mean. They're saying here is 3, and then we have 4 terms, and then 96. So they're saying what is the terms between. So it's just other terminology. If you see a geometric mean, it's, so what do? Well, this is the first term. What term is this? 2, 3, 4, 5, 6. Yeah? So how would we figure this out? What are we missing here? Missing R. Yes. So we know this, we don't know R. So 96 equals, I'm subbing it into Tn equals T1 R to the power n minus 1. So the first term is 3, and I don't know R, but I do know n. What's n? 6. So if I subtract 1, I have to the power 5. So if we undo things, we go in the opposite order of bed mass, right? So I can divide the 3 out of there, and what do I get? 32 equals R to the power 5. And I think most people know what the 5th root of 32 is, but maybe you don't. Yes, R is 2. So we're actually doubling each time, so we get 6, 12, 30. Whoop, maybe I don't know what I'm doubling. Try again. 24, 48, 96. So then you might say, well, what does that mean? Why did you introduce geometric means? Well, look at this. If I take 3 and multiply by 12 and square root it, what do I get? 6. If I take 6 and multiply it by 24, you might need your calculator for that at that point, but I guess it's 144 because the square root of 144 is 12. So that's what's happening here in the geometric means. Yes. And that will work for any geometric sequence. Yes. Try it out. And on and on and on. Yep. Yeah, it's kind of cool. Okay. So given that term 1 is 81 and term 6 is 1 over 729, find the geometric means. So, same thing. Term 1 is 81, and then we have 2, 3, 4, 5, 6, right? Is term 6, right? Term 2, term 3, term 4, term 5. So, we don't know ratio again, right? Yeah, so 1 over 729 equals first term, which is 81, R to the power, I guess it's 5 again, hey? Because there's 6 terms, yeah, so 6 minus 1 is 5. So I can get rid of this by dividing, and you might go, oh my gosh, that's a little crazy. It's just 81 times 729. So you have a calculator. It's 1 over 59,049. And you might not know the cube root of that is. It's not the cube root, sorry, it's the 5th root. But your calculator does 5th roots. Do you know where to find 5th roots? Yeah. Yeah, well, it depends. If you have a graphing calculator, you go to math and it'll be all there. But on your little, I don't say basic calculators, it's scientific calculators, it's something like this. And you have to know that the 5th root is the same thing as to the power 1/5. Okay, so I would not, does everybody know the 5th root of 1 is 1? Like, whatever root of 1 is 1, right? So, you know you're going to get 1 over something. So just 5th root 59,049, and just make sure you put it as a denominator, right? The correct answer would be 1/9 for the ratio. So we're not done yet though, of course. We have to actually find the terms there. So if I multiply 81 by 1/9, what do I get? 9. If I multiply 9 by 1/9, what do I get? 1. If I multiply 1 by 1/9, what do I get? 1/9. If I multiply 1/9 by 1/9, what do I get? 1 over 81, and then of course I should get 1 over 729 if I multiply that by 1/9. Okay, the third term of geometric sequence is 10, the sixth is 80, fine. So T3 is 10, term 6 is 80. What do I do to figure this out? Yes, you rename this as a special T1, sorry. And if I rename term 3 as term 1, what's this going to become? Term 4, very good. So if I do that, I can figure out the ratio, right? So 80 equals term 1, which is 10, r to the power, what? Yes, 3. So I divide 80 by 10 and I get 8. So can anybody tell me what r is? R is 2. Very good. So the generating formula, of course, I need to find the term 1. Fastest way probably is to take the third term and go backwards. What's the second term? And what's the first term then? 2.5. So Tn equals 2.5 times 2 to the power n minus 1. So there's my generating formula. I have a bunch of dots here, so maybe I'll use a bracket instead. This is 2.5. You could also have it as 5 over 2 if you wanted. The eighth term, of course, would be T8, would be 2.5 times 2 to the power 7. What do we... Is what? But then times it by 2.5. What do you get? 320? Yes, okay. Okay, 320. Okay, moving on. Who's a piano player here? Holly is? So when we watched that video about the golden ratio, they were talking about the frequency here. So they're saying that the lowest note is 27.5 hertz, which is C8. Sorry, A0 or A0 if you want to call it. The lowest one. The highest is 8 octaves higher, which is the C note, and that's 4,186 hertz. So determine the common ratio produced from the lowest key to the fourth key at 32.7. Verify your common ratio by using the highest and lowest. So term 1 is 27.5, and the fourth key would be term 4 is 32.7. If I'm using that, right? So 32.7 equals 27.5 r to the power 3. I don't know what the problem is I don't know what the highest note term is. So this is the easiest way to find the ratio, right? So what do I get? I divide 27.5 into 32.7 and then I cube root it. You don't know? You need a calculator. So r to the power 3 would be 1.189090. So it's repeating. So if I cube root that, I get 1.059428. Hey, is that close to my golden ratio? Yeah, it's 1.6. I was just playing with you. Okay, so it's saying verify by using the highest frequency. The highest frequency was 4,186. So what we're trying to find is, could we get the 88? Did you know there's 88 keys in the thing? Well, it says that. The 88th key is the first term, which is 27.5 times this ratio I just figured out, 1.0594 blah 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 to the power n minus 1, which would be 87. So punch that in your calculator and you get approximately 4,174.16. So it's kind of close to what you're supposed to get, but obviously we rounded a few times there. And I'm sure when they gave me this information on 27.5, it was rounded in the beginning. Okay, the population of Airdrie, Alberta experienced an average annual growth rate of 9% from 2001 to 2006. The population in 2006 was 28,927. Estimate the population for 2011. So, 2001 was term 1. That's not the population. So then we have term 2, term 3, term 4, term 5, term 6, and that was 28,927. When they give you the rate is 9%, that means you are gaining 9% each year. So you still have 100 plus the 9% gives you 109%. So my common ratio is 1.09 as a decimal. So I need to figure out what the first term is. So term n equals term 1 r to the power n minus 1. So 28,927 is term 1, 1.09 to the power 5. So I need to divide that to get it to the other side. So term 1 would be approximately 18,801. So once I know that, I can find 2011, which is term 11, based on our pattern there, would be 18,801, 1.09 to the power 10, which is approximately 44,509. And in 2030, that would be term 30, which is 18,801, 1.09 to the power 29, which is approximately 228,849.